Anybody pick a u? You pick the u to be the denominator. That's what I would pick. Oh, not only because the hint told me that, just because, oh, I want an x in there. Is it 2x? Sorry about that. So then my du is 1/2 2x to the, what? What's my derivative of that? -1/2 dx. So if I just try to substitute it in, I really like that I have this, but what's not matching? My who? The derivative. So could I have taken out this half and put it out in front? Is that better? Or is it still not a match? Still not a match, is it? So what can I do? It's similar to what we did earlier when we kind of mess around a little bit here. What can I do with what I've got on the board here? What can I say about the square root of 2x? What's that equal to? What's the square root of 2x equal to? U minus 1? Would you agree with that? What can I do? What do you think we could do? How would it be just 1 over u? Say that one more time.
So you have your the square root of u minus 1.
Okay, so let's hang on with that thought. Okay, the square root of 2x is equal to u minus 1.
And then if you substitute that back in, you put your 1 plus the square root, well, just the square root of 2x.
So you want to plug it in right here.
Yeah.
What about the, aren't I trying to get a dx to match? Aren't I trying to get a dx to match? How am I going to do that? What do you think? It's a nice idea though, huh? So if we plug this u minus 1 right in here, you see maybe the issue is this guy right here? Yeah. It's kind of like that little secant problem that we spent a little time on, isn't it? Say that one more time. Oh, what were you thinking? Oh, like we did before? Maybe. Well, I'm looking for this guy in yellow. What guy in yellow? This guy in yellow? Yeah.
So if you separate it up into 1 plus 1 over square root of 2x.
So you want to make it a fraction of 1 over 1 plus 1 over the square root of 2x? Is that equal? You can't separate fractions that way, can you? Yeah, good try. I mean, you're just trying things. I mean, that's what you got to do. So let's think about what we have here. I'm going to rewrite this du for a minute. And we've got du equals 1 plus 1/2 2x to the negative 1/2 dx. Would you agree with that? That's not what I have? Thank you for not agreeing, because there is no 1. Is that okay? Go ahead, one. Oh, okay. So we've got to have more to this. We have to have that. So Lydia, where did you get that green 2? Okay. Everybody understand where she got that? And those will cancel. So now I've got du equaling just 2x to the power negative 1/2 dx. Would you be okay with that? So if I'm trying to replace dx, what do I know about dx? What could it be equal to? So what would dx be equal to then, Claremont? What would you get? To the negative 1 power, right? So would it turn into just, would it just turn into that? And do we know something about that? This is really close to the value of u, isn't it? So if I go back up here, 1 dx is really going to be equal to what?
U plus 1 or U minus 1?
How'd you get u minus 1?
Because the fractions are the same except for the U has a 1 extra.
So you're looking at this u, you're looking at this, and you're seeing they're the same except for,
U has 1.
so you want to put u minus 1 in the numerator for dx, because dx is in the numerator? Would you guys buy that? And what would you put in your denominator? Now, Nathan, what you did earlier, can you do on this one? So you need to try a couple like that. Those are hard. Those are definitely difficult. Okay, those are definitely a whole lot. Okay. So you have one to try, you kind of have a model now to try from. Okay. So you have notes there in front of you. We're going to do a few of these. So let's get to where we're at. We're on this section here. Okay. So what we're trying to do is we've been looking at natural log. So what is it that you know about the natural log function? What does it look like? You got a couple things about natural log. What's its base? Okay, so a natural log function has the natural log of x. That's what a natural log looks like. Or it will be e to the x. So we know that this natural log and the letter e go together. So what we were doing is that these two things are what of each other? They're not the same. They're the what? What's another name for opposite? They're the inverse, right? Well, that's all right because they are the opposite. They're the inverses. So what should happen when I compose them from last section? When I put these two things together, what should I get out? X. That's exactly right. So that says if I take F and compose it with G. And so who is G? Who is G? You see it right to my right? So would you agree with that? If these two things are truly inverses, this better result in the value of x. Agreed? All right, so let's do that composition. So we're back to kind of algebra 2 composition. So I'm going to take my function, and in place of x, I'm going to put the natural log of x. My input goes into that position. And what I'm going to try to do is find out what that's equal to. So right now I'm going to set it equal to some variable r. It doesn't matter what I set it equal to. I just chose r. So how do I get an exponent to fall down? Okay, the natural log of my left-hand side equals the natural log of my right-hand side. I'm going to rewrite that. Would you agree that exponent fell down? And what is the natural log of e? 1. So what does that tell you? If these two logs are equal, what does that say? So if these two are equal, what two letters do I know are the same then? R equals X. Good. Well, what was R again? And who did I define it to be? Who did I define it to be? So e to the natural log of x is equal to x. We just did a proof. That's a true statement. So you might say, well, where am I going to use that? Take a look at number 2 in the example below. I can now use that e and natural log cancel each other. So if I had to simplify, we're not taking derivatives, we're just doing pre-calc algebra 2 stuff right now. Can you simplify y? What's it going to be equal to? It's that easy, but it's hard to remember, I think. Okay, but natural log and e cancel each other. So let's look at the other direction. So now I'm taking g at f of x. So I'm taking g at f of x, which is e to the x, according to my function on this side. I plug that in, and I get natural log of e to the power of x. I insert it right there. You with me on that insertion? You okay? Well, we're in logs. So what happens here? What happens to this exponent? Because I'm already in a log. Property says it drops down. And what does the natural log of e reduce to? So we know that it's equal to simply just x. So now we know that the natural log of e to the power of x is simply just x. Notice they're inverses of each other, so my output was simply x. So now, what can you simply say that this example is equal? There's no work to do. What's it equal to? 2. Done. This one's a little bit more intuitive, I think, than the first one we did. What's the answer to number 3? That's it. So part of your homework tonight is just going to be looking that over. Now, we've got 2 days to do this. Okay, so I'm going to do one more little part to you because it's something to review. There's some hints. If I want to remove exponents, how do I remove exponents? I go what? Go logging. All right, just as you said. Go logging. And what's the other thing I might want to remove? What if I want to remove logs? What do I need to do? Go what? That's exactly how I say it. Go exponentiating. I don't know how to spell it, but go exponentiating. Okay, so I have logs. I want to remove them. So what do I need to do? Go exponentiating, but I can't right now. Why? All right, so what could I do to kind of merge some things together so I can notice my eventual goal is to solve for y? What could I do? Can I get the logs on the same side? Ooh, minus. What does that minus say I'm going to end up doing? It does say I'm going to divide, doesn't it? So now I've still got my logs, but I'm merging them together so I only have 1. Okay with that? Now what do I do? Let's see. Remove logs, go exponentiating. Who's my base? Who's my power on D? Remember this little thing? Who? Negative x. So e to the negative x power is equal to what? Y minus 2 over the sine of x. What's my goal? How? I like to put it in that direction, and then what else do I need to do? Add 2, and that's equal to y. Notice that sine x is by itself. The 2 is not with the angle measure. I can't change it. Okay, so that's how you would go exponentiating. Guess what we're going to have to do in number 2? Go logging. How am I going to go logging on this? Can I move anything over, or am I ready to go? Why would you use ln? Is that an okay step? I skipped one. Are you all right with that? For the left-hand side. That's why I went logging. So then I'm going to take the natural log of the quantity 2 plus cosine x. I'm almost, so what's my last thing I need to do? And done. So logs really help us out. I know for a long time you actually despised them. It was awful. But they actually really help us out. Okay, so my exponent rules. I put a big fat time symbol there, not to confuse you, just so you understood it was multiplication. What does that turn into when I use my exponent rules? What's going to happen? It's my base. E, and what do I do with the x and the y? So I'm just reviewing with you some log rules. That's it. What do I get? X plus y. Okay, number 2, how could I simplify that? What would that turn into? What does a negative power tell me I have? 1 over e to the x. Good. Okay, that's what that means. So we're just kind of going through this like, okay, what would this look like? Now I'm adding my exponents. Can you go the other way? When I add, what does this really turn into? Oh, yeah, e to the natural log of 2 times e to the what? What can I do with that 3 that's laying down there? What could I really do with that? Could I do like that? Is that what you meant? Is that a true statement? So you can't forget all your log properties. Wait a minute, we just did this problem, didn't we? What's this going to turn into? You just reduced e to the natural log of 2. What did that reduce to? First problem we did today. 2, on your notes, I should say. Okay, what does this turn into? So what's my end result? 2x to the third. Nifty. Okay, what are you going to do on the next one? What is that? What can you do with that? That means division. So how would that look? E to the power of 2x divided by what? Would this be okay? Is that what that means? Keep my base and subtract my exponents. Are you okay with that? Or not? Molly, you have a question on that? You all right? All right. So what can I do with the numerator? Anything at all? Is that equal to 2x, or does it have to be a natural log with it? So it's just equal to what? E to 2x. I can't do anything with it. What's the denominator equal to? Just what we did today. And it is over x. So we're just kind of using those rules that we had today. So let's turn your paper over and let's do just this first part, just the derivative of e to the x, and then we're going to stop. The derivative of e to the x. Do you know what it is? You don't. You shouldn't know. But you have to know how to deal with it. Do you think you want to do the definition of a derivative? Could you imagine what that would look like? E to the x plus h minus e to the x all over h? That doesn't really tell me anything, does it? What is it that you do know the derivative of now that's related to e to the x? Oh, you know this. We prove that using the definition of a derivative. So any ideas? How would you attack this problem? How would you attack this problem? Notice, this is one way. It's kind of the way I just said, but that's okay. We'll do it again. E to the x plus h minus e to the x all over h. We could mess around with that, but I don't know what I could do because I'm subtracting two bases, so it's not division. I couldn't combine them because it's not multiplication, because that's what exponents mean. So that might be a method of attack, but yeah, I don't see anything. So is there any way I can bring in a natural log to this? Okay, so if I apply it to both sides, I'm going to get, let's see, natural log of y equals, and I'm going to write all my steps down. Why did you choose a natural log? And what happens when I take the natural log of e to the power of x? What do I get? Have I taken a derivative yet? Or am I just rewriting the problem? Yeah, I haven't even taken a derivative. I'm going to rewrite one more time. Natural log of y equals x. Would you agree with that? Okay, now let's take the derivative. What is the derivative of the natural log of y? Keep going. 1 over y dy dx. Good. That's called implicit. Equals, bless you. What I do to the left, I need to do to the right. What's the derivative of x? 1. Do I need a dx dx? No, we haven't written that. We could, but what's dx dx sound like it's equal to? Okay, so who am I trying to solve here for? Well, if dy over dx is equal to y, what is that? Who is dy over dx equal to? Who is y? Go to the very beginning of the problem. Oh, it's right here. So guess what? It equals itself. How awesome is that? So the derivative of e to the x is e to the x. So knowing what we've done before, let's forget the integral. We're going to come back to that. Knowing what we've done here, what do you think the derivative of e to the sine x is? Spit it out. What do you think it is? Keep going. Keep going. Times who? Where the heck did that cosine x come from? Chain rule. Dang it. Chain rule is every single time. Okay, what's going on in problem number 2? You can't just say, well, this is easy. What's going on here? You got to look at the problem. So it's a, what kind of rule am I going to have to apply? The chain rule or the product rule? So what is the product rule? Derivative of the first, which is just e to the x, times the second plus the first times the derivative of the second. What's the derivative of the natural log of x? Now we like you to take it a little bit further. What is common in both of those terms? So I'm going to factor it out. What's left? Very good. So do you kind of like the derivatives of e to the x? Shoot, they're much easier than we have been doing, aren't they? What are you going to do on number 3? What are you going to do? How far do I want to go? I know you're waiting for that quiz. Can you just take the derivative of this? What are you going to get? Is it product rule? So what's the derivative first? Times plus the first times the derivative of the second. Well, what's the derivative of e to the negative 2x times negative 2? Okay, how could I simplify this sum? What could I factor out? And a 2? Okay, what is in this spot if I've pulled it out? Lots of you, maybe not in here so much anymore, but lots of people just leave it blank. What's it really equal to? Remember, redistribute. What else do I have? Ooh, probably not going to be plus, right? What's it going to be? Minus. And what do I have left? Would you agree? I think I could go a step further, huh? 2, go ahead, yeah. The ones actually cancel. Look how nice that worked out to be. So this polynomial actually can be added together, huh? Okay, so that's as far as we can take it today. You can see tomorrow we'll be doing some integration and practicing e to the x, but e to the x's are not bad. So this is where we'll take off tomorrow, is right on this, and then you'll integrate. So see, your homework says day 1 and